Hello guys. So today we are going to solve one of the dynamic programming question, climbing stairs. It is a very popular question and it is also very important to understand. So let's quickly jump to the description of this problem. So you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways you can climb to top of. Okay. So whenever we have to reach to the top of the stair, we can only take one or the two steps, right? This is what the constraint is. So whenever you have multiple choices, right, like one step, two step, three step, or four steps, right, if you have multiple choices, generally one pattern we would be looking at through which we can solve these kind of problems very easily. Only the part we have to think is before jumping off the any recursion problem, what we should be doing, right? We should be thinking in terms of our recursion tree. So let's try to build the recursion tree, right? So let's say that you have total three steps, right? And you have to reach to the top. So if you think in other way, right, from zero, if you have to reach to the top, right? So what happens if you are already on the top and you want to reach to zero? So either you can take, so there are two choices, right? One, you can take one step or you can take two steps, right? So what happens if I reduce one step? So I will be reached to two. If I mean, if I previously took two steps, so I would be at one, right? So here also, if I'm at two and I have to reach to zero, so again I can have two choice, right? I can take one step or I can take two steps. So if I'm taking one step, right? So where would be I would be standing right previously. So I would be at first stair, right? And by taking one step only, I would have reached to two, right? But if previously I would have taken like two steps, then obviously I would have reached to zero, right? So this is one this is one valid path, right? This is one way that I could have reached to three. What is the other way? Again, I have here like two choice. So if I would have taken one step, so it means I was there at zero and I took one step, then I would have reached to two and then I would have reached to three, right? So this is also like a valid path because I was able to reach to zero. But if I would choose like, but this is if I will reduce two, it will be minus one. So this is this is not the possible path, right? Because I can start uh, my journey only from the zero step, not from the minus step, right? So so this is one path, this is another path. Um, the same case can be here also. If I would have taken one previously, then this will be then I would have been standing at zero, zeroth position. Or if so, if this is one step, right? If this is two step, this would be in the minus. So this is not a valid case. So this is another one path, right? So one path, one this path and this path. So total we have three ways to reach to zero. Or in other way we can say from zero we can reach to three in three ways, right? This is the same thing. Okay, so how should we write the function? So the template which I'm going to use today, that will be a template which I will be using in most of the recurrence problem, and that is very important to understand because the same recursion kind of problem, people write multiple ways, so it's very confusing for if you're trying to understand the recursion first time. So let's quickly try to write the code and then I'll explain it. So related to any recursion problem, one actually two steps are there. One is the recurrence relation you have to find, other is what is the base case. So let's say you have this function, right? And the way the first step always you should be do is you should start building your recursion tree. So the recursion tree we build, right? And the way we build it, we were at the top and we were trying to go to the zero. So I'm saying that whatever is my current position in the staircase, so my current is representing that. And if my current is less than zero, it means this is not the valid path, right, for me. So in that case, I don't want this value to be included in my answer case, right? If my current is equal to zero, it means this is a valid path through which I can reach to the n. And I want this path to be included in my answer. That's why I'm returning one because I found one way, right? Once I reach to the zero. Now there are from here, right? One thing what you can do is you can have one answer and you can say stair count. Okay. Now in current, so let's say you are at the third position. You remember we were taking one step, right? Or we were taking two step. So I have two choices, right? So if I would have taken one step previously, so that's why I'm trying to find what was my previous value. So current minus one step, and this is my current minus two step, right? So one or two step only I can have. And whatever the values are going to return from these functions, right? So value is only going to return one if, let's say if I'm choosing one step, so it will return only one if there is a valid path. The same case is also here. And I want to, whatever the result is there, I want to add them, right? Okay. So that I can find all the number of ways, all the distinct ways, right? And simply what I can do is I can return the answer. And other part which I have to do is I have to call this function, right? So initially I'm at the top initially. So this n value I'm taking and just I'm subtracting till I reach to the zero. Same thing what we did in the recursion tree thing, right? This is one way to write your function. One second. It's okay. This is one way. So let me quickly just try with five stair or something. Okay. So this is working. Now the same method. Okay. Let me just quickly submit it actually. So I will just put a LRU cache here so that our answer would be submitted because we don't want to recalculate the same number of steps, right? Um, if you remember, let me just quickly show you why we are doing this LRU cache. So you remember we were, when we were at three step, so previous steps would be either if you would have taken one or two, so the recursion tree would be look like two, one, right, zero, zero. Again here, it is one, right? So this will be zero or this will be minus one, right? So again, this will not be a valid case. So if you see, we know that if we reach to one, we can only have one way to I mean from one we have only one way to reach to zero, right? But in this case we are kind of recalculating all these things. So when you will build a recursion tree for the higher numbers, there are multiple calculation that is going to repeat. So those things we are going to cache it. So for that reason, we are using this LRU cache, right? And that is inbuilt function in the Python, so we can take advantage of it. Okay, so let's quickly, submit it so that we get to know, okay, this function is working. But the same function can be also written as right? The same function can also be written as for loop, and I will explain what it does actually, right? And most of the function, right, the recursion related, the problems and the DP related problems, I'm going to solve using this one template so that you will not be get confused. So here what the thing is, let's say the answer is there, right? So I will call my stair count, okay, and from my current I can do minus I, and that's all. This should also return me the same answer. Okay, so how it is working is, so you the basically let's understand it, right? So this particular template, what it is saying is, at every step, right, when the function is starting, at every step you have two choice, right? Either you can take one or you can two plus one I'm doing because our loop can go from one to two, right? So two should be included. That's why plus one I'm doing. So at every step I have like two choices, one or two. And from my current, I am, reducing one choice one by one. So I reduce the one choice, I call the recursion again. So it is going to explore all the path by using one. Once it will reach the base case, it will try with the other option. So in that way, the same recursion tree is going to build what we were building earlier, right? And and this basically the variable which will hold the count of all the number of ways, okay? Because we are also, returning this answer in every current path. So I hope this makes sense, because same code you can write multiple ways, and this is one template which I will be using in most of the problem. So you should be very clear, and this is only the way we are going to write. In other case, the problem is, though it's look easy to write the code, but sometimes it's very hard to figure it out. The multiple in the multiple problems. How I mean, it's up to you. If you find very intuitive the other template, you can always use that. But I find myself this template very intuitive because I think about the number of choices that I have. So even if tomorrow there are, from one or two or five steps you have, I can just put this constraint here, right? And the same step you can take multiple times, or you can choose one choice only one time. All these constraint would be there in the future questions. So we'll try to understand how to use this particular template. So let's see. Let me quickly first submit it and show you this template also return the same result. Okay, and see you in the next problem. Thank you guys. Let me know if you have any question or comments in the comment box. Thank you.